Okay, this is a file when I open OIE, and here shows all the hierarchy of this product. I should have already explained in the earlier part of this class. Now I just want to demonstrate how to make a few parts and make a quick assembly for the existing structure. So we're going to start it from column, and then beam and slab, and under each you got you should have this start with drive, which is have all the driving forces, all the setup elements, and this is going to contain the actual geometry for the body part of the column, for instance. So right now let's start from the drive. So again, if you we're currently in the project workbench, so if you double click, that will lead you switch to the geometry workbench. What we're going to do is we're going to open that file as a separate file, so we're not confused by this little bit complex tree structure. Okay, so the way we open a new window, if you highlight this product, right click, and then go into this object, click open new window. So that gives you solely the part file for that drive. And switch back, we also need to get this type 1 open the new window as well. Okay, so we got two files. Now this one, let's just shut this one down. Otherwise you will work on two files which both loaded the part file. As you'll see from this warning, you may have unpredicted unsafe behaviors when you do undo and redo operations. So let's shut this one, the product file, down. Just click yes. So make sure you currently work on this file, drv drive. Okay, first of all, let's create a geometric folder, insert geometric set, name it as say set up. Okay, so what we're going to do, we're going to make a point, click a point by coordinates. We're currently working on a millimeter, so we say with 5 meter, click OK. This button here going to maximize all the views. Based on that point, we're going to draw 3 lines represent X, Y, and Z direction. So this is a line. Let's say point direction. You got also many other methods as well. We just use point and direction. So make sure point, you click this point direction. We can either pick from this coordinate system. It's a y-axis, okay, and length, let's make it 30 meter. View, that's 0. So you can also drag the other side. You see this one will change its negative value. Okay, click OK. And if you double click this icon here, it will continue to create lines until you press escape key. So if I double click, ask me to get a second, so point again the same. This time direction, you can also right click, take X component, and this one we put 20 meter this time. So if you click OK, yeah, it will pop up again because that is being highlighted. You double clicked, so it's just continue to promote this window until you press escape. So point again, same point. Direction, right click, go to that component. Height, let's give it 18 meter. Sorry, 15 meter for now. Right, so now we cancel, see that being deactivated. Okay, so this is it, and we save, and they will be served as the driving file. We later might need create 3 planes. Let's see, just keep it for now. Okay, switch back to the column. So in here, we need to insert a few geometric set. You can also click from this icon here as well. If you don't have it, you should be able to right click from a blank margin, and the one you have, oops, yes. So you can check and check to show you different tool set. Okay. So this is one insert. which is this one. Yeah. All right. So now we're gonna do insert a geometric set. We're gonna insert 3. First, we call it input. Second, we call it reference geometry. Oh, wrong spelling. Geometry. Okay. Last, we call it output. Alright, so now start from input. If you remember last time we draw a column through profile, this time we're going to do a column through footprint first. So we need to have the central point for the footprint. Let's create a point. Okay. And now we're going to do is draw a sketch. So if you do sketch reference, you can just pick this XY plane. Original, we're gonna use projection point and pick this point. So that point will become the original point for that sketch drawing. Click OK. Now let's just draw a rectangle. Okay. Now we need to locate this rectangle, taking this point as a central point. So the way we do it, we're gonna draw a construction line by taking this line, and also you need to click this one so that whenever you draw now will be counted as a construction geometry, which will not be shown when you exit the sketch mode. Okay, so if you draw, you see that dashed line. Yeah? So if I exit, it won't show, right? Okay, so come back here, and we pre-select this point, hold Control down, so you can do multiple selection, and then this is useless. And then click this by defining dialog box. You can take midpoint, click OK. Alright, and now next tab we're gonna double click that one to constrain this one and this one. Okay, and so now deactivated that. What we can also do is you can right click, go to definition. See, that's a name. You can name it as, say column type 01 width. Okay. Click OK. The reason why it doesn't show is because you need to click name value display. And you can change that value to, let's say, 500 millimeter. This one to say 700 millimeter. Put this one down a bit, closer, down a bit, and right click, same trick, will show that. Okay, you can also change that, click more, let's say column type 01 less. Okay, so all the constraints will be shown on the spec tree. Okay, with the name associated with the model or the drawing here. Alright, now it's also become a green, means it's fully constrained. You cannot change it unless you change the parameters of. So now if we exit, and let's name this one. By the way, you can do right click, go to properties, or you can just do Alt plus Enter. Alt plus Enter. I call it sketch column 01 footprint. Okay. Click apply. Okay. No. Okay. Now what we gonna do is to insert a solid folder. See, because I was in input that as the current work object. Therefore, the newly inserted body will be right after that. And what you can do, you can right click here, come to your other children, and so we pull this one down. Okay, so name it as a column type 01 body. Okay, good. So that's being underlined. We're going to use pet, pick this sketch, let's give it 9 meter. Okay, click OK. Oops, sorry, it's not 900, 9 meter. Right. So next we're gonna make some customized parameters to control this column, this rectangle column. The way we do, I've already made those parameters. So basically, what it is like is maybe I delete one and just okay, maybe delete this one. Okay, so type 01. Okay, H. So the way I do it, go to Tools, Formula, and then you click New Parameters. Change this one to column type 01 length. Length. And here you can give the dimension, which is that, and also make sure that it's length. Okay, here, right? That's length. You can also got many other type of parameters as well. So the one we it's a little bit. That's the one created. Should be length. Apply OK. So see, and you can also order. Okay, so we got those parameters. And the way we link that, first of all, let's link the height. Height, which is, well, I've already got the length, so this one should be height. Let's call it height. Okay, and height should be, let's say, 14 meter for now. Okay, now first let's link this extrusion, right click from here, right click, edit formula, and pick this. Okay, and the length and the width should be linked to the sketch. So if you double click, it's being automatically hidden. So see that's being shaded. So the way to unhide it, either you highlight and do Ctrl H, see that, or you can right click, just doing this one, hide and show. Alright, so double click. This 500 again. Double click this constraint, right click from here, we take width, click OK, and this one double click. This time, instead of taking from trace, we can also choose from this window boxes. The one we do is you highlight renamed parameters. You see that's all the customized parameters, and we'll take L. You have to double click, pop up here. That means that linked with that parameters, click OK. Click OK. So now if you exit, this column is fully controlled by those parameters. Okay? So change that to OK. Good. So we got the first part of this column done, and then we're gonna add a little nose. If you see from the picture, I'm gonna find it. It's in my computer somewhere. Hong Kong U. Right. Course tutorial. Sorry, it should be project brief. So come to the photo. If you look at maybe this one, okay. So this node, that's what we're gonna create in the next step. Okay. So it looks like this is the one element. This is inserted into this column. Alright, so what we're going to do, let's say, first of all draw a sketch from input again. So right click, define work object, draw sketch. This time I'm going to use this support reference as this face. Click, see, pat, face 1. So okay, and we click OK. So we're going to draw using polyline, draw a triangle. Okay, and it automatically applies some constraints such as horizontal and vertical. If you don't want that to be automatically applied, you can just deactivate this one, geometric constraint, also dimension constraint. So now, whenever you draw, even you do like horizontal, you will not apply any constraint at all. Okay, so by default it's being activated. So one thing we just constrain this triangle. First, I'll double click this one, so I'll coincident to this face, right click, doing coincidence. And then I will link this with this point. So this dimension I will put as double click 7 meter. Okay. And also, oops, not this one. This dimension plus this dimension. So I'll put this one as 400. Not 4 meter. 400. And this one as 600. Another thing is in digital project, instead of press enter, which will exit the whole window box, you can just do tap, which will still stay in that window box, so that you can continue to edit other variables within this window box. Click OK. So now this is fully constrained or green color. Exit. Now let's switch back to a okay, let's rename it first, call it sketch column type 01 a nose. Okay, so now switch back to this current work object to body, and we still use pad. We pick this sketch this time, reverse direction, and instead of using dimension, we use up to plane. We take this plane. Okay, click OK. Good. See, that's one entity. Now what we're gonna do is we will make that little chamfer. If you look at this one, right? So the way we do it, we're gonna use that's a sketch being hidden. We can switch back to the sketch. I'm using this chamfer button. Click this one and this one. Click. Just click yes. So we can change this angle. Double click to 19. We can also change this dimension, let's say to 100. And the solid will be updated automatically. Alright, and then we're gonna pocket out this middle bit. See, which is the gray part. So basically, what we do is we create a new sketch. Right click, switch back to no. This time I'm gonna use reference geometry as the geometric set to store the sketch. Okay. So we need to create new sketch. Right. The way we do it, we're gonna draw a sketch through the central point and in parallel to this face, which is actually the Y and Z plane. So what we do is we first of all create a plane served as a reference for the sketch. So if you click plane, this button here, you can say parallel through point. Reference will be, you can take this face. Point will be this point. And now let's make a sketch. So see, plane is that plane. Sketch, we will take this plane and we just click OK. So we're gonna draw one thing. Oh, this button here, if you click it, will be change you to normal to the sketch view. So what we do, we can draw a rectangle. Make sure that is bigger than its nose. So the way we do it, we can constrain, double click this line to this line, this line to this line, and this length. This length. Okay, so this one put it at 100, so it's always bigger. This one is 100, this one as okay, maybe we can That's okay. Right, as long as it's bigger than this node, it should be fine. Wait a minute, this one, we want to hollow this one out. Therefore, okay, let's put it 100. Sorry, we delete this one. We change to another way, so we link to this point and this line. Make it 50, okay? And this direction is okay. Change this one to 50 as well. So what's gonna happen if we, let's see, that's 100, 150. So what will happen? Change to 800. If we exit, we're gonna use this one as a pocket to pulling out some of the mass from this column. The way we do it, first of all, let's rename this one as pocket nodes. Okay, so switch back to this work object using this pocket. Click this profile, and dimension wise, we can say up to this plane, we do offset as a, how many, 100. Let's try what happened. Give it a negative figure. Right, and we can, what we can do, we can mirror it. So that's normal to plan, so correct. This same. Oh, wait a minute, if we do this one, 100. This one will be to this plane, offset. Let's say minus 100. Preview. See, that give you that pocket. Click OK. Right. Okay. Now we're gonna do is okay. We got this little nose. Maybe we make it a little lower to 12 meter. Okay. Right. Next up, we're gonna make a recess. To make the upper part slender. So the way we do it, we're gonna draw a sketch on this plane, this top plane, which is like offset from the periphery of this, the outline of the top rectangle, and then we again pocket off some of the mass up to some point here. Okay, so I'm going to show you how to do that. First of all, let's say we will have again in the back to reference geometry, and we'll draw a sketch based on this face with the original point as the projection point of this point. Click OK. Right. So now we're going to draw a rectangle, and the same, we create construction diagonal line and make this line, hold Ctrl down plus this point, click this button here as midpoint. Okay, now we're gonna double click this constraint, this one to this one, this one to this line. Okay, and alright, so you need to create a parameter called REC, which is a recess wall thickness. Okay, through this method, click this one, just give the name. So now I'm gonna link. Maybe I just do it so I can see. So basically, I'll copy this one. What you're gonna do? I'll delete this one, so I'll create a new one just to show you. Again, it's a length. Click new parameter. That's the name you're gonna give, and make it 120 for now. Apply. Click OK. So we got new parameter created. switch back to this sketch. So if you double click this one, what we're gonna do, alright, sorry, we make it a bit more interesting. So instead of link to that distance, we constrain to the width and length. Right, so if you double click 400, right click, edit the formula, we're gonna make some little, very simple computation. So we're gonna take this width, the minus this thickness, click OK. That will calculate the result and apply as the parameter to determine this width. Click OK. And same idea to this length. Right click, edit the formula, pick up this one minus again the wall thickness. Click OK. Right. So now exit. Okay. So from here, if we see, let's unhide this sketch. No, that is sketch. Let's call it sketch a recess column upper. Okay. Apply, click OK. So what we're gonna do is we're gonna use again pocket. So we right click, switch back to this body, use pocket. So pick this sketch. Need to specify a plane. So let's specify the plane. Maybe okay. We can either do by dimension, or we do, see if we do plane. We need to have a reference plane. Okay, let's do dimension. So this one, let's say 3.5 meter. Bit more, 4.5. Or maybe, wait a minute, we can do is we do, that is 7 meter. Okay, let's make it be more interesting. So because if you remember this sketch here, this triangle sketch, this 7 meter, we can create new parameter to link this one, so we don't have to access back to the sketch to control this height. So what we're going to do, we create, let's say, a new parameter. Let's call it nose height. That will control the top surface. We'll make it 7 meter, maybe 7.2 meter. Click apply, and we link this one. Double click, right click to this nose height. Click OK. Now if you exit, right, so see under parameter we got new one created, and come back to this pocket. Now what we're gonna do is we will okay, we'll do this way, using pocket, pick this sketch. We say by dimension, and this time we will edit formula. So formula will be take this height and we minus this height and minus, let's say, half meter. Make sure that it's lowercase. Okay, click OK. Preview. Oh, see, it take the middle part as hollow. Yeah. So what, instead of taking the middle part, what we can do is we will take a. If you click thick, preview. See, actually take a thickness driven by this parameter. At the moment, I put 200. So we're gonna kind of like pocket off the thickness, and to have this recess result. Okay. So if I click OK, now that is what you get. So basically, if you change this one to say 6.5 meter, that's all updated. It's all clinked, pretty neat. 7 meter. Okay. Right. So that's a column. And lastly, we can make a shell, because well, if a concrete is okay, but if you do like steel, what we can do is still within C, that is vertical current work object. You can using this shell function, just click shell, that tell you the wall thickness. If you say 20 millimeter, right? That's inside. Outside you can put it 0. You can also say which face is going to be removed. So if you click this one and click this one, it turns out to purple. So you got the 2 elements which you can access here. You can replace or remove, right? And if you click OK, it will seek this object throughout. See? Okay. And because it's concrete, therefore we could just right-click deactivate this one. For now, it become solid. Right. So next, we're gonna make a mirror it, and we also create a like array of it. Let's hide this sketch, which might be a little bit. Right. So the way we do it, we first of all, in order to mirror it, we need to create a central plane for that to be mirrored. Right. And then also the space. So let's make one thing is a first line. First line gonna be saved into the reference geometry. So I will create a line, pick by point direction, pick the point, taking which direction? Taking my direction. Okay, let's take my direction. 20 meter. Right. This is a line. Okay, line 1. And then we create a plane. Let's say parallel to point. No, let's do normal to curve. So you'll ask which curve, pick this curve. By default, it will take a middle point. You can also create a new point if you want. But I will take middle point. Preview, click OK. So this plane, let's call it plane mirror central. Okay, click apply, and then we'll take this plane to mirror it, and we also need a spacing to array it. So first of all, let's make a spacing parameter, make sure that it's length. Let's call it column type 01 spacing, give it 6 meter. Click apply, OK, and switch back to this as current work object, and we first of all make a mirror, which is this one. Yeah. So click mirror and select. See, that's a prompt. Select a plane or a face. So let's select this plane. Click OK. Let's be mirrored. Again, populate it within the same body, and then we're going to use a pattern. So if you don't have that box toolbar displayed here, everything can be found from insert and go to transformation. So basically, all those operations within this section can be applied to solid. All this will be applied to wireframe surfaces. Then when we use transformation, change to rectangle pattern. And spacing, we will link add formula to spacing, this one, column type 1, spacing, double click OK. Number will take 6, reference which will be the direction of this array. So we'll take X direction, X axis. You can preview, right, click OK. Right, done. So that's the column. Okay. So now whenever you change one column back here, change the parameters. Let's say this one, I'll give it 800. It all updated easily, right? also this height. Great. So this file pretty much done, and so if you want to insert this one assembled to the product file, all we need to do is to locate from that point and then orientate it by this line. So before we switch back to the drive part, still one more step. In the input part, this point at the moment, if you right click, see parent and children, see the parent is this absolute axis system, because that is based on coordinate system. So we need to isolate that one so that this point don't have any parent. So when you assemble to another file, there won't be any problems by asking to apply the input parent. The way to do it, right click, just doing isolate. See, that's been broken. So now if you see parent and children, there's no parent, there's nothing, no information to drive this point at all. So that's safe. Okay. So we save the file. Okay. Now what's gonna happen if we open the product file for structure column? Okay, so let's open. That's a structure column product file. See, digital project product file. Though the others are part files. Click open. So this one be automatically loaded, right? And you can move it. So switch to assemble, and using this manipulation, let's move this bit. Move out. Right. Okay. So what happens is we can link this. Let's first of all fix this point. So that's under. Okay. The one thing is we currently under this product file, which is assembly workbench. And in order to link different geometry within different parts, yeah, you need to first publish the geometry. Then you can link them under the level of product. So for this file, which is a part file, what I need to do is I will have to publish all those geometry. Yeah. So if I multiple select them, go to Tools, click Publication. Just click Yes. See, that's got one set created with all the geometry published. Okay, and for this file, I need to, at the moment I'm currently working on this part file, so I need to switch back to this part file. So unfold, double click this one. Now I'm in this part file, type 1. Okay. What we need to do is we publish this line and this point. So again, go to Tools. Let's publish this plan as well. Okay, Tools, Publication, click Yes. Okay. Now you see that's the 3 publications. So we're gonna link this line with this line. Yeah, this point with this point. Okay. So the way we operate, we have to switch back to upper level of the product. Double click this one. Okay. Now now let's apply a constraint between different parts. First of all, we need to have an anchor point, so that when you apply the constraint, one part, which is this drive file, will not change. Okay. So let's do this one. We can change to top plan view. Oops. So let's make this point. Let's fix that one. fix component. Okay, click fix. See, that's new constraint. And next we do coincident. Click this one. So this point will be this point, right? Until you click this update, to move it to the place, right? And now we need to rotate this part, the whole part. This part 90 degrees, so that this will be aligned to this line. The way we do it, first of all, we can rotate a little bit. Say we take this, so we basically this is around a customized axis. So we need to, first of all, again, you can follow this prompt. Select a line to define the rotation axis, which will be this line, and we will rotate. Okay. And now we apply an angle constraint, which is this one, angle constraint, right? Click that, we pick this line plus this line, and make this angle 180 degrees. Click OK, update, bingo. So now it's constrained. So see, those three constraints is applied to the same level as those part file under this product. So now I save. The best way to do it through save management. So you see, those are the modified file. You can just click save. This one will be save. This one will be save. That is open, so nothing changed. So just click OK. Right. So now we finish the first part of the exercise, the column. Let's stop recording and create new file before it's getting too big.